Okay, part 2. So in part 1, we kind of went step by step and made some tables looking at different transformations. Like we looked at we didn't call them by these names, but where we changed the amplitude there. We changed the period here in the second example, made it go faster. We did a horizontal translation here, which we normally call a phase shift when we're talking about sinusoidals. And then we did a vertical translation where we shifted it up to. Now, doing it by these tables is a good way to do it if we forget some things or need to do it really carefully, like step by step. But as you can see, it's pretty tedious. So it'd be nice if we just remembered what these different transformations did, and then we could just apply them without having to do like a whole table. So here's a little table for our transformations of sinusoid. So you can see the like general form. So here's sine and one for cosine. They have the same transformations that happen to them. So there are kind of 4 different spots where things happen. This A being multiplied out front right here changes the amplitude. So notice right here, it says absolute value of A changes the amplitude, like that's telling you what the amplitude should be. So if there's not a number out front, it's just automatically a 1, like our parent graph. Notice also if it's a negative number in front, it's going to change the amplitude and also flip it over. So it makes the amplitude like -2. So normally where the max, like if it was normally, our sine function looks like this. If we had -1 in the front, then it would start at 0, but it would go down first and then up. If, reflection about the midline, that's what we call it. Okay, B right here, the next little piece, the next transformation can happen is this B. This is like when we did sine of 2x in the example above. And a lot of times we'll write it with another set of parentheses right here. I actually like it with another set of parentheses where the B is inside the parentheses, so it's really clear there. So B changes the period. That's when we talked about like going around the circle 2 times as fast or something like that. So there are kind of 2 different things that you can see about B right here. 2 different ways to think about it. So one way to think about it is that B tells you the number of cycles in a horizontal distance of 2 pi. So for instance, when we did sine of 2x, we were going twice as fast, so we were able to get 2 cycles in 2 pi time. So B tells you the number of cycles. Or you could also say, well, the period is 2 pi divided by B. So in our example where we did sine of 2x, it would be 2 pi divided by 2, which is pi. And we saw that we were going around 2 times as fast. So we made it around in just pi. So these are 2 formulas to either keep kind of handy, or I normally think of this second one. This kind of lends itself to more of my thought process of we're going 2 times as fast. So if it would normally take 2 pi, it's going to take us pi. That follows a little more of that second train of thought there. Okay, we can also have, there's the H right here. Notice it's written in the formula as minus H. So H is what we call a phase shift. That's like a horizontal shift. And you can see that we can go left or right. We just have to be careful when it's left or right. And then the last thing that can happen is this K all the way at the end. So this is outside of the parentheses, it's outside of the sine or cosine function. So an example of this would be like our sine of, x plus 2. So it's all the way on the outside. You could also have it written in the front, like it could be 2 plus sine of x, because we can add or subtract, or we can add in any order. Or if we had sine of x minus 2, that could also be written as -2 plus sine of x. So it's just totally separate from the sine or cosine, just adding or subtracting on the outside. And that is going to shift us up or down. So this is our vertical shift. And you'll notice that these letters are kind of the same letters we used when we did transformations of logarithms and exponentials. So you kind of seen these before. Hopefully it should be okay. But this could be a good thing to keep handy for a while. Okay. All right. Now we're going to do some practicing. So example, we're just going to identify the features. So we're not even going to graph. We're just going to say what these features are. So here's our first one. We have 4 sine of 6x minus 2. So there are 3 things going on here. The first one, the amplitude, that's the number that's being multiplied on the front. So our amplitude is going to be 4, meaning from the midline, we're going to go up 4. Our graph is going to go up 4 and down 4. Okay, wherever that midline is. Reflection, okay, a reflection would happen if that number in the front is negative. It's not, so nope, it's going to be our normal shape where it goes up. I guess we should pay attention that it is a sine function. So it's going to go start in the middle, go up, back to the middle, down and back to the middle. Okay, period. So we have changed the period. 6, we're going around the circle 6 times faster than normal. That's what it's saying. So 6 times faster. If it normally takes 2 pi to go around, but we're going 6 times faster, we're actually going to get around in pi thirds. And if you need to break that down a little bit more, remember we have that formula. The period is 2 pi divided by b, and our b in this case is 6. And we can simplify that 2 over 6 and write that as just pi over 3. Another way to think of that 6 is that in 2 pi time, we're going to get 6 full cycles because pi thirds fits into 2 pi 6 times, clearly. Okay, and our midline, so what's going to affect our midline? Well, that's going to be affected by this minus 2 at the end. Minus 2 is going to shift the whole thing down 2. So including that midline, the midline is going to down 2. The midline always starts at y equals 0, like it's the x-axis. So if we shift it down 2, it's going to end up at y equals negative 2. That's going to be the formula there. And a phase shift. So a phase shift is if we're adding or subtracting anything right next to the x. We're not adding or subtracting next to the x, so there's no phase shift. Nice. Okay, that's that first one. Let's look at this next one. So notice the parent function is cosine. Kind of interesting. All right, first thing we're going to look at is the amplitude. So we're going to look at what's being multiplied to the outside of the cosine. It's a negative 1/3. So the amplitude is going to be 1/3. Which is interesting. So normally it's negative 1 to 1. That means we're only going to go up 1/3 and down 1/3 from the midline. So it's kind of squished together closer to the midline. So our amplitude is 1/3. Reflection, yes. So normally cosine starts at the top and goes down and then back up. But since it's reflected, we're actually going to start all the way down to the bottom and go up and come down. So that's what it's going to look like after it's reflected. Okay, period. Look next to the x. Is anything being multiplied right next to the x? No. So our period is just regular. We're not going any faster or slower around the circle. So our regular speed is, it takes 2 pi to go all the way around the circle. Midline, so are we shifting up or down at all? Yep, we're shifting up 1. So normally we're at y equals 0. If we shift up 1, we're going to be at y equals positive 1. And a phase shift. So we're adding and subtracting next to x. We're doing a minus pi. If we're doing a minus pi, that actually means we're going right pi. So normally our graph would start at the top and go down. But remember, we're doing a reflection. So we're going like this. Bam. And that ends in 2 pi. But since we're shifting to the right pi, we're actually going to start at pi, hit the top there, and then hit the bottom at 3 pi. So the whole thing's just shifted to the right pi. Alrighty. One more. Notice the parent function is cosine. Okay, remember our parent cosine function starts at the top, goes down, and then back to the top. Okay, amplitude. Look right here. There's just a negative. There's no number. When there's just a negative, that's really just like a negative 1. So our amplitude is 1. We haven't changed our amplitude. That means from the midline, we're going to go up 1 and down 1 for our wave. Reflection, it is negative, so yes. That means that our graph is actually going to look like start at the bottom and go up and then down. Okay. Period. We are changing the period because there's something being multiplied to the x on the inside. We're going 1/3 the speed, meaning we're going slower. We're going 3 times slower, right? So if we're going 1/3 the speed, if it normally takes us 2 pi, but we're going 3 times slower, it's going to take us 3 times longer to get around, right? So our period is actually going to be 6 pi if we're going 3 times slower. Another way to think of that is we have that formula that says 2 pi divided by that number b, which is 1/3. But when we divide by a fraction, we need to flip and multiply. So that's 2 pi times 3 over 1, which gets us that 6 pi. Okay, And our midline, are we shifting up or down at all? Yep, we have that -4 hanging off all the way on the end. So we're going down 4. So instead of our midline being at y equals 0, we're going down 4. It'll be at y equals -4. And lastly, a phase shift. That would be if we were adding or subtracting anything to the x, but no such luck in there. So phase shift, no. It's just going to start in its normal place. Okay, so that's identifying features. Not so bad. We just kind of take it piece by piece and keep going. Okay, example 2, match the equation to the correct graph. So I'm just going to look at, we'll just start at the beginning and see how it goes. How about that? So let's look at 2 sine of pi halves x. I'm noticing first that, well, first, none of them have phase shifts. That's interesting. Nothing's being added or subtracted to the x's. None of them have phase shifts. And they all are changing the amplitude by 2 or -2, which means we're going to like wiggle up and down 2 from our midline. Also, none of them are shifted up or down, so they're all centered at 0. Okay, well, it's not super easy to narrow these down, but let's see. Let's look at all of the sine functions first. So I'm going to look at this one's a sine, sine, sine. Oh, the first 3 are sine on top. Okay. Okay, so one of these, I noticed that one of them has that -2, which means instead of going mid, max, mid, min, it's actually going to be reflected. So it's going to go down and then up. So I'm going to look for one that starts in the middle. This one starts in the middle, but then goes up. This one starts in the middle, but then goes up. Aha, this one starts in the middle, but then goes down. So this one here, D, is that sine function. You can see that it starts in the middle, goes down, middle, and then back up. But it's reflected from that -2. Also, let's see if we can deal with that 1/2 sine of x. So we're going half the speed. So if it normally takes 2 pi to finish, and we're going half the speed, it's going to take us 4 pi to finish one cycle. And there's 4 pi right there. So you can see that whole cycle took us 4 pi. So I think, whoa. This one, 2, is going to be D. All right, one of them is narrowed down. Let's look at the cosines now and see if we can narrow one out like that. So cosines, once again, one of them is flipped over. So cosine normally starts at the top and goes down and then back up. But if it's flipped over, it's going to start at the bottom and go down and up. So let's look for one that starts at the bottom. Aha. This one right here, C. Starts at the bottom and then goes up and down. Okay. And let's look at that period, because the period's being changed there too. Once again, the period is 1/2. Well, sorry. We're being multiplied by 1/2, meaning we're going around the circle at 1/2 speed, half the time. Normally it takes us 2 pi. If we're going half speed, it's going to take us 4 pi. And you can see once again that we, this one here is completing a whole circle in 4 pi. So I think we can match C with this guy right here. All right. Now, let's look back at our sine functions. So the only difference between these is one of them is being multiplied by pi halves, and one of them is being multiplied by 1/2. Okay, let's look at the 1/2 first, and then narrow it down. So, multiplied by 2, this one has the normal speed, but it should be going up to 2 and down to 2. But we're going half the speed, meaning it's not going to finish a full cycle until 4 pi. It's going half the speed. So let's look for one of these that starts in the middle. It goes up to 2, and it finishes in 4 pi. I think we found one. B would be a good candidate. Starts in the middle, goes up to 2, back to the middle, down, and finishes in 4 pi. So I think this B right here, B, is going to be matched with 3. All right, 3 down. Nice. Now the only other one that looks like a sine curve, so the only one that starts in the middle, which is 1, the only other sine curve we have left is this little wiggly guy down here. I just want to make sure that it matches up with this period. So pi halves, that's kind of an interesting thing. We're going pi halves the speed. That's not as easy to figure out how I normally like to. So this is a part where I would probably use that little trick to do 2 pi divided by this number, which is 2 pi divided by pi halves. When I divide by a fraction, you need to flip and multiply. So 2 pi times 2 over pi. Well, I have a times pi and a divide by pi. And then I just have 2 times 2. So it looks like a period. It should be done in 4. Just 4. And that's what we're seeing down here. It goes from 0 to 4. So F. Let me connect to that first one. Awesome. 2 more left, and we have something similar going on here where one of them is 1/2 and one of them is pi halves. So for 1/2, that's going to take us 4 pi to get around. For pi halves, like we just did with the sign, that's going to take us 4 to get around. So let's look here. Here, this one's period is 4 pi. So this should be this one right here. And the last one, we should have a period of 4. Awesome. E goes right here. Whoops. Wonderful. Let me make that yellow. Cool. Fade BC. Okay.